Good day, everyone. So we will be having another module for today here in our subject Math 152, Math 171, Module 10. So this module is another part of our differential calculus or calculus 1. So today we will be discussing another topic which is polynomial curves. So ang topic na under nito is sa second derivative test and point of inflection. So sa previous module natin, same lang din yung topic na polynomial curves, but doon kasi is iba yung subtopics niya. So dito ang subtopic is yung dalawang nabanggit natin dito sa ating presentation. So before we dive deeper dito sa ating dalawang subtopics ng polynomial curves, let us first give the learning objective ng ating module. First, to discuss the properties of concavity of curves. Next is for us to be able to apply the second derivative test to find maxima and minima of a function. So kanina naghanap din tayo ng maxima and minima. Pero ang ginamit natin doon is the first derivative test wherein nung nakahanap tayo ng critical values of x, kumuha tayo ng interval from its left and right value. Then sinubstitute natin sa f prime of x. Then na-identify natin yung maximum and minimum values sa ating critical values nung chinek natin yung change in sign of our f of x prime. But in this module, module 10, ang gagamitin natin is second derivative test. So later, i-discuss natin paano nga ba siya gamitin in identifying the maximum and minimum values of our given function. So next objective is for us to be able to use the critical points to determine a curve. Okay? And define the point of inflection na mai-discuss natin to sa point of inflection na part. And then lastly, to solve for the point of inflection of the curve. Okay, so let's proceed to our discussion in our module 10. So we have here the so-called concavity and the second derivative test for maxima and minima. So as you can see here, we have the graph of a function. So let's just say na ito ay f of x is y is equal to f of x. Okay. So makukuha natin yung second derivative or yung y double prime by simply getting the derivative of the first derivative. Okay, by definition, second derivative or y double prime is the rate of change of the first derivative. So, as you can see dito sa ating graph, doon tayo sa portion sa baba. Okay? So, doon sa portion kasi na yon, after mo doon sa may lowest point or the minimum point, yung ating y double prime doon is positive and then magi-increase na yung ating y prime as the x values increases. Okay? So, as you can see here, dito sa point, ito yung minimum point ng ating given graph. Okay? So, pag nag-proceed na tayo, magiging increasing na yung ating y prime. So, yung slope natin dito is increasing habang tumataas yung x values. So, dito yung x value is 0. Then, habang lumalayo, yan yung ating x values. Nag-i-increase yung x. And then, yung tangent daw is nagte-turn or umiikot counterclockwise. So dito sa ating lowest point, 'di ba flat lang siya? And habang umaandar siya papataas, 'di ba yung red line na 'to, para siyang umiikot, 'di ba? So kung dito is flat siya, so pagdating dito sa point na 'to, siguro pag ganito na yung direction niya, nakaslant na, 'di ba? O pagdating sa point na 'to, pwedeng mas mataas na yung slope niya. So habang tumataas 'yon, makakarating siya sa highest point. So sabi dito sa ating illustration, sabi sa minimum point daw, andon ang graph ng curve doon is concave upward. So as you can see, pag sinabing concave upward, para siyang siguro parabola or curve, tapos ang opening niya nakatutok sa taas. Okay? So on the other hand naman, kapag ang ating point is dumaan na sa highest point ng ating curve, yung ating y double prime is negative na daw. And then yung ating y prime or yung slope is nagde-decrease na. Then yung tangent natin, ang rotation niya is clockwise direction. So andito yung highest point, hindi ba? So after dyan, pababa na. So of course, negative na yung slope. And then itong tangent na to is 0 yan, di ba? So pag nakarating ka sa point na to, ang tangent natin, pag ganyan na, di ba? So umikot na siya in clockwise manner. So pag daw nasa maximum point ka, ang curve daw doon is concave. As concave downward or nakaturo yung opening sa baba. Okay, so as simple as that. So, meron tayong tinatawag na concavity test. Pag sinabi natin concavity test, meron tayong first scenario. So, if f double prime x or ito yung y double prime is greater than 0 or positive sa lahat daw ng x, And then the graph of the function is concave upward. So ito yon. Kapag naman daw ang f double prime of x is less than 0 or negative siya sa lahat ng x values, ano, sa x in interval I, yung graph daw natin is concave downward. Okay? So for second derivative test, for maximum and or minimum or maxima and minima, so ito yung parang criteria natin. So at a point, y prime is equal to 0. So it's either dito sa lowest point or sa upper point yun. Y is maximum. Okay? So sabi din dito, if y double prime is positive kasi greater than 0, y is minimum. So kapag daw ang ating y double prime is positive, nandun daw tayo sa y minimum, meaning nandito tayo. Okay? O yun yung minima. Pag naman daw yung y double prime is equal to 0, the test fails. Okay, yung nakalimutan natin sa umpisa, if y double prime is less than 0 o negative, pag yung negative daw yung y double prime, ang y natin is maximum na dito siya. Okay, so medyo contradicting yung um, idea, no? Kapag kasi positive yung y double prime, minimum. Pag negative ang y double prime, maximum. Okay, basta kabaligtaran, parang kabaligtaran. Pag nag-zero naman siya, nag-fail yung test natin. Okay? So let's proceed to our examples para mas maintindihan natin kung ano nga ba yung module na dinidiscuss natin ngayon, particularly sa concavity and second derivative test. So here we have example number 1 here in module 10, second derivative test. Find the maximum and minimum points of the function by the second derivative test. So kanina, first derivative test yung pinagamit sa atin. Wherein nag-set lang tayo ng interval ng x values na critical values ng x. Left and right niya. Tapos sinubstitute natin sa f prime of x. Then tinignan natin yung changes in positive to negative or negative to positive na sign. So na-identify natin doon kung alin sa critical values natin yung maximum and minimum points. So dito sa ating module 10, second derivative test yung gagawin natin. So mag-i-introduce tayo ng bagong way. So, bago tayo mag-arrive sa second derivative test, of course, kunin muna natin yung first derivative natin. So, yung first derivative natin is magiging 3x squared plus 3x minus 6. Okay, so kunin muna natin yung ating critical values of x. Paano natin gagawin yan? I-equate natin siya sa 0, yung y prime natin. So, yung 3x squared plus 3x minus 6 can be divided by 3. Kumbaga, ilo-lowest term natin. So, magiging x squared plus x minus 2 is equal to 0. Since x squared plus x minus 2 can be factored, ang factor niya is x plus 2, x minus 1 is equal to 0. So, makakuha tayo ng critical values of x na x is equal to negative 2 galing dito sa first binomial. Then x is equal to positive 1 galing sa x minus 1 is equal to 0. So, ito yung critical values of x natin. So, of course, pag ginamin natin yan, makakukuha tayo ng critical values of y naman. So, paano gawin yun? Balik tayo dito sa ating original function. Substitute natin, if x is equal to negative 2, our y value will be equal to positive 6. And then, pag x natin is equal to 1, our y is equal to negative 15 over 2. Therefore, ang ating critical values is negative 2, 6, and positive 1, negative 15 over 2. Okay? So, nakuha na natin yung critical values. Ngayon, i-identify natin alin sa kanila yung maximum and minimum points. So, paano natin gagawin doon? Papasok na ngayon si second derivative test. So, using second derivative test, okay, so syempre, second derivative test nga, kukunin natin yung second derivative. So, y double prime is equal to 6x plus 3. So, ito yung i-analyze natin para makuha yung ating second derivative. So, now we have second derivative. Ang gagawin natin, kunin natin yung dalawang point natin, yung critical values. So, gamitin natin yung x values nila. Sabihin natin, x is equal to negative 2. So, ito yun. Dito muna tayo sa first critical value. Then, y double prime is equal to 6 times negative 2 plus 3. So, 6 times negative 2 is negative 12 plus 3. Y double prime is equal to negative 9. So, tingnan nyo itong nandito sa ating, sa upper left ng ating screen. Meron dyan nakalagay na second derivative test for maximum or minimum. So binigyan tayo ng tatlong criteria. Okay, so ito, kapag daw ang y double prime is less than 0 or negative, y is a maximum value. So kumbaga yun yung maximum point natin. Next, kapag yung y double prime is greater than 0 or positive, yung y naman doon is minimum and yun yung ating minimum point. So kapag naman yung y double prime natin is 0, then yung test natin is fail. Okay, so meron din tayo ditong concavity test na tinatawag na kung saan yung f double prime x or yung y double prime is greater than 0, then yung ating graph doon is concave upward. So sa kabaligtaran naman, kung ang f double prime of x is less than 0 or negative, ang graph natin doon is concave downward. So since dito sa ating y double prime is negative 9 sa negative 2,6 na point, therefore, ito yung ating, check natin dito sa second derivative test. Doon siya magpo-fall. Doon siya magpo-fall sa first criteria wherein y is the maximum value. Therefore, yung negative 2,6 na point, yun yung maximum value natin or maximum point. Yung negative 2,6. Okay? Then yung graph niya is, tingin naman dito sa concavity test, pag negative daw yung yung f double prime of x, concave downward. Concave downward. Yung isa naman ang i-analyze natin, x is equal to positive 1. So y double prime is equal to 6 times 1 plus 3. Y double prime is equal to 9. Positive. So kung positive ang y double prime natin, papasok siya dito sa pangalawa. Therefore, yung y natin doon is the minimum value. Or yung ating 0.1, negative 15 over 2 is the minimum value or minimum point. Negative 15 over 2. So, ang graph nito is concave upward. Bakit, sir, concave upward? So, positive 9, saan siya magpo-fall? Dito siya magpo-fall. Concave upward dyan. Ayan. Okay. Kung i-graph natin siya properly, so ganito yung magiging itsura niya. Okay, so ganito yung magiging itsura niya pag ginraph natin. So ito yung maximum point natin, yung negative 2,6, which is na-verify natin kanina yun yung maximum point using the second derivative test. And also sabi natin, based on concavity test, concave downward. So as you can see here in our graph, concave downward pala talaga siya. So on the other hand, we have the another point, which is 1, negative 15 over 2, na determine natin siya using second derivative test na siya ay yung minimum point ng ating function. And at the same time, concave upward yung kanyang graph using the concavity test. Okay, so I hope clear ang ating discussion here in our first example using the second derivative test in determining kung ano nga ba yung maximum and minimum point of the given curve or given function. Okay, so dito binigyan tayo ng curve. But kung napapansin niyo yung curve dito is unusual, hindi siya yung may coefficient na number talaga. Pero yung coefficient na binigay sa atin is A, B, and C. Yan ay mga numbers. Okay, so real numbers naman yan. Pero binigyan tayo ng mismong critical point. So hindi lang natin alam kung alin dyan yung maximum and minimum. So ano kaya ang pwede nating gawin dyan? So pwede nating gawin dyan is i-substitute natin yung values ng x and y based sa points natin. So bakit natin pwedeng gawin yun? Pwede natin gawin yun dahil itong point na to is dumaan sa ating function. So pag sinubstitute lang natin yan, makakakuha tayo ng mga values. Sige, try natin. Y is equal to ax squared or ax cubed plus bx squared plus cx plus d. So gamitin na lang natin yung coordinate na 0, 4. Okay? So, substitute natin yung y which is 4 is equal to a. O 0 yung x natin cube plus yung b natin, then yung 0 na x squared plus yung c plus d. Ay, yung cx walang x na kalimutan natin, 0. Anyway, ito yung 0 na to, 0, 0. So matitira is d is equal to 4. So ngayon meron ka ng isang value, meron ka ng d. So kailangan mo na lang hanapin is yung um, A, B, and C. So next is gamitin naman natin yung 2 saka 0. Kung meron tayong makukuha value. So yung y natin is 0. Then yung A times yung 2 na x, cube yan, plus B. So 2 squared plus C times 2 plus 4. Yung D natin, yung nakuha natin kanina. So simplify natin, we have 0 is equal to 2 times 2 is 8A plus 4B plus 2C plus 4. So meron tayong equation number 1. Okay? So ngayon, ang gagawin naman natin is try natin kumuha ng derivative. Kunin natin yung derivative or first derivative ng given function. Consider natin that A, B, C, and D are all constant. Or kumbaga coefficient, number lang sila. So y prime is equal to 3A x squared plus 2bx plus c. So since meron tayong critical points and alam natin sa critical points, di ba? 0 ang slope natin doon o yung first derivative. So equate natin sa 0. So ngayon, gamit tayo ng isa sa kanila. So kahit ano dyan, gamitin na lang natin is 0 to 4. 0, 4, sorry. 0, 4. So 0 is equal to 3a or the 0 yan squared plus 2b 0 plus c is equal to 0 siya. Ito. So ito ay 0, ito ay 0. Therefore, yung c natin is equal to 0 lang. O meron ka ng D, meron ka ng C. So A and B na lang yung kulang natin. So try natin gamitin yung isang point naman, yung 2, 0. At 2, 0. So yun pa rin, yung first derivative pa rin yung gagamitin natin. Equal yan sa 0. So 3A times yung x natin na 2 squared plus 2B. Yung 2 na x plus yung c na 0, pwede natin ilagay din. Okay? So ngayon, yan ay magiging 3 times 4 is 12a plus 4b is equal to 0. But since yung 12a and 4b is divisible by 4, kung pwede natin silang i-multiply by 1/4 both sides of the equation, you will have 3a plus b is equal to 0. So now you have equation number 2. Okay? Etong actually yung equation 1 natin class is pwede pa natin palang i-simplify. Ano? Pag sinimplify natin yan, ay multiply lang natin sila in 1/2. So, i-edit lang natin para mas simplified na yung ating equations. So, yan ay magiging 4a plus 2b plus c plus 2. Okay? Equation 1. Sige, may equation 1 ka, equation 2. So, try natin na mag-elimination siguro. So, using equation 1, 4a plus 2b. Diba nakakuha na tayo ng c? Pwede na natin i-apply dyan yan. Plus 0. So, kahit burahin na natin tong 0 para hindi maraming nakasulat. Plus 2 is equal to 0. Tapos, yung equation number 2 natin na 3a plus b is equal to 0. So, pwede natin gawin, ito pa lang second equation or equation number 2, pwede natin i-times 2 yan. So, magiging 4a plus 2b plus 2 is equal to 0. Then, 2 times 3a is 6a. Then, 2 times b is positive 2b. Tapos, 2 times 0 is just 0. Over. So, para magkaroon tayo ng cancellation, minus yung gamitin natin. So, minus 2b minus 2b is 0. 4a minus 6a is negative 2a plus 2 is equal to 0. So, solve natin yung a kasi solve naman na natin siya. So, we have 2a is equal to positive 2 over 2. So, a is equal to 1. So, meron ka ng a, c, d. So, nawawala na lang is b. So, pwede natin masolve yung b. Gamit na lang tayo. It's either equation 1 or equation 2. Pero mas madali, gamitin natin yung equation 2. 3a plus b is equal to 0. 3 times 1 plus b is equal to 0. Therefore, b is equal to negative 3. So, kumpleto na yung ating variables. We have a is equal to 1. B is equal to negative 3. C is equal to 0. Then D is equal to 4. So, substitute lang natin dito sa given function natin. Okay? y is equal, yung a natin is 1, hindi na natin isusulat, so yan ay x cubed. Plus, yung b natin is negative 3, then x squared, plus yung c natin is 0 times x, plus d na 4. So simplify lang natin, y is equal to x cubed minus 3x squared, cancel 0 na yan, plus 4. So since ang pinapahanap lang naman sa problem or sa example number 2 is yung mismong coefficients natin. So yun na yung sagot natin na. Ay damay na rin natin yung mismong equation of the curve para para makuha yung 0, 4, and 2, 0 na critical points. So dito sa ating example number 2 is kumbaga para siyang bumalik tayo sa algebra, no? So in-applyan lang natin siya ng konting concept ng integral, particularly sa derivative test natin sa first part natin wherein sa critical points yung slope natin doon is equal to 0. Okay, so sa part na ito yung class. Okay, so we also have here the point of inflection. Okay, so pag sinabi natin point of inflection, of course, it is a point along the curve wherein nagkaroon ng changes from concave upward to concave downward. So for example, meron kang curve na papaganito or po pwede naman papaganyan kasi po pwedeng nag-change yung curve nyo from concave downward to concave upward. Ano? So yung point wherein nagkaroon ng transition yung direction ng ating curve, yun yung tinatawag nating point of inflection. So possible sa halimbawa yan yung curve natin, possible nandito yung ating point of inflection. And on the other curve na dinrawing natin, possible nandito yung point of inflection niya. But how will be able to identify kung nasaan ba yung point of inflection? So we will just use the point of inflection test. So yung isang function f of x, is meron daw point of inflection at a, wherein yung a is a number sa x-axis. Wherein pag ginamit natin yung value ng a, sinabstitute natin sa second derivative, ayan, dapat magiging equal to 0 daw siya. Pag nag-equal to 0 ang second derivative ng ating function, therefore, yung ating point of inflection is nasa x is equal to a. Okay? And the second derivative changes sign. So, kumbaga, from positive siguro, tapos biglang naging negative. Doon yung inflection point ng ating function. So, another sabi, if the second derivative is 0, pero yung third derivative is hindi equal sa 0, gamit yung x is equal to a, ibig sabihin, yung point of inflection ng given function f of x natin is nasa a. So, para mas maintindihan natin, i-try natin mag-solve ng examples. So, we have here an example sa pagkuha ng point of inflection of the given function. So, binigyan tayo dito ng y is equal to x cubed plus 3 halves x squared minus 6x minus 4. So, dito, I think ito yung kanina pa nating example na paulit-ulit. So dito, example ulit natin siya sa pagkuha ng point of inflection. So paano ba tayo kumuha ng point of inflection? So una natin ginagawa is kinukuha muna natin yung derivatives, first and second derivative ng ating function. So gawin natin yun, kunin natin yung first derivative niya. Ang first derivative niya is 3x squared to plus 3x minus 6. For the second derivative, meron tayong 6x plus 3. Okay? So for point of inflection, sabi dito sa ating point of inflection test, ang isang function daw is merong point of inflection at x is equal to a kapag nag-equal daw siya sa 0. Okay? So meaning, itong 6x plus 3 natin, yun yung second derivative natin, i-equate natin siya sa 0. So now we have 6x plus 3 is equal to 0. Therefore, we could solve for the value of x. So transpose natin yung 3 sa kabilang side, magiging negative 3. Then i-divide natin both sides by 6 para makuha natin yung x. So divide both sides by 6. Then magkakaroon tayo ng x is equal to negative 1/2. So nandito, yung x value na to, nandiyan yung ating point of inflection. So para makuha naman natin kung asaan yung y, siyempre hindi lang naman siya x value kasi coordinate o point yung hinahanap natin. Therefore, hanapin natin yung ating y value. So paano? I-substitute natin doon sa ating given function. So if x is equal to negative 1 over 2 or negative 1/2, yung ating y is equal to, pag sinubstitute natin dito, So y is equal to negative 1 half cube plus 3 halves negative 1 half squared minus 6 negative 1 half minus 4. So yung y natin is magiging equal sa negative 3/4. So ang point of inflection natin is negative 1 half negative 3/4. So ito na ba ang ating point of inflection agad? So i-check muna natin yan. So gamit yung point of inflection test. So para matest natin ang ating point of inflection na nakuha, yung negative 1 half, negative 3/4, kuha tayo ng dalawang near values ng x natin, which is yung negative 1 half. Sabihin natin, meron tayong x is equal to negative 1 half. Yan yung x value ng ating inflection point. So near value, so mag-drawing lang tayo ng number line dito. So halimbawa, ito yung ating negative 1 half. So of course, yung magiging left value niya is, sabihin natin, negative 1. Then yung kanyang right value is 0. Okay, kumbaga ang interval niyan is 1 half, then 1 half. Okay? So i-analyze natin yung x is equal to negative 1. So ito ay isa-substitute natin sa ating second derivative. Okay? So ang ating second derivative is 6x plus 3. So 6. So yung negative 1 na x na gagamitin natin. Tapos plus 3. Second derivative will be equal to negative 3 kapag ang x natin is negative 1. Pero kung ang x naman natin is equal to 0, which is yung nasa right ng ating x value na negative 1 half, ang ating second derivative will be equal to 6 times 0 plus 3. Yan ay positive 3. Okay? So as you can see, yung ating negative and yung ating yung second derivative natin is nagbago from negative 3 papunta sa positive 3. Okay? So meaning, yung curve natin, so as you can see, yung second derivative natin is nagbago yung kanyang sign. So gaya kanina, nung diniscuss natin yung concept pa lang ng point of inflection by definition is a point wherein nagkakaroon ng changes ng direction sa second derivative. So as you can see dito, nag-change ng sign, meaning nag-change yung direction ng ating second derivative. Therefore, we could conclude na yung negative 1 half and negative 3/4 is point of inflection of the given function. Pero hindi pa tapos, i-verify naman natin siya using yung second statement, itong number 2. So basta nag-change ng sign, ta same value pa din. Kagaya ng ginawa natin dito. Okay siya. Point of inflection talaga siya. Pero this time, i-verify lang natin siya sa statement number 2 natin. So sabi dito sa second statement, yung second derivative daw is 0 kapag ginamitan natin ng x is equal to a. Pero kapag yung third derivative niya is hindi nag-0, doon verified na point of inflection nga yung nakuha natin. So try natin yung second derivative. So nasolve naman na natin kanina, yung x is equal to 1 half, 3/4 yung nakuha natin, hindi ba? Pag yung negative 1 half. Pero kunin natin yung third derivative. Ang third derivative niya is, so sabi dito, if the second derivative is 0 kapag ginamit natin yung x na a, tapos yung third derivative naman is hindi equal to 0 pag ginamit yung x is equal to a, then yung nakuha nating point of inflection is a point of inflection of the given curve. Kumaga tama yung point of inflection na nakuha natin. So meron tayong second derivative dito na 6x plus 3. So, pag ginamit natin yung negative 1 half na x ng point of inflection, ito ay 6 times negative 1 half plus 3, or yan ay 3, negative 3 plus 3, yan ay 0. Di okay yung first part ng statement natin. But for the third derivative, yan ay 6 na. So hindi siya equal to 0. Therefore, we could finally conclude that negative 1 half, negative 3/4 is the point of inflection of the given function. Okay? So kumbaga na-satisfy natin yung second statement. If the second derivative is 0, since nag-0 yung second derivative natin, okay. But the third derivative is not equal to 0, hindi siya 0, 6 siya, di ba? So therefore, yung ating point of inflection na nakuha is tama. So yun na yung final answer natin. So I think that would be all for our discussion in our Module 10. If you have clarification, kung nagugulahan sa concept kasi ito ay more on application na ng ating differentiation, you could raise your concern sa ating connection sa group para malinawan kayo sa mga parts na clouded or magulo. So thank you for watching and thank you for listening to our lecture video for today.